Hello student, welcome our channel The Physics Point. In the previous lectures, we are just started discussions about the gravitations, the detailed informations, and such a basic informations about the gravitations. Whenever we discussions of the gravitation chapters or the gravitations concept, we are going the deep about how to originate the concept of the gravitations and what are the basic roles or who was the basic or who was the main persons which are try to discover or major roles in the formation or in the discovering of the gravitations. The gravitation is the force of only attractions of that particular planets, and this force is dominant or this force is active on the each and every object. These are related to the particular planets which are lies on the particular planets. Then the whenever we discussions of the gravitations, we are just discuss the Kepler's three laws, just give the detailed informations about the Aryabhats and how they can be gives the informations of the motion of planets. And then after 5000 years of the Aryabhat, then the new scientist John Kepler, which is formulated three laws about the planetary motions. First law is the law of orbits, second law of equal laws of aerial laws, and third law is law of time periods. And after that, we are going to discuss the Newton's laws of gravitations or universal Newton's law of gravitations must be known. Then at that time, we are just discuss the force of attractions or the what types of the forces will be acted between the two objects which having the different mass or which having the same mass, and they are placed at a distance. The force of attraction between these two objects is directly proportional to this product of their masses. That is, we are taken the first object having the mass m1 and taken second object having the mass m2, and the center to center distance between these two objects it will be r, or certain books it will be explained as a d. Then the force of attraction between these two objects which having the mass m1 and m2 is directly proportional to the product of their masses and inversely proportional to the square of distance between these two objects. Then the distance will be certain times d or r. And whenever we study the proportionalities or in the relations or in the variations, direct or indirect variations, that times we have one of the constant of proportionality. In the gravitations, we are using the constant of proportionality, that is g, caps G. This is known as universal gravitational constant. They are having certain standard value at every place on the earth. G is equal to 6.67 into 10 raised to minus 11 Newton meter square per kg square is the unit of that constant. After that, we are just to discuss the such a relations or the relations between the second Newton's second law on this Newton's law of gravitations, and we get one of the another concept about the gravitation, that is acceleration due to gravity. When we are throw the object upward and they again comes towards to the center of the earth, and it changes continuously changes their motion and it changes their speed. Whenever they changes their velocity, acceleration will be produced. What types of the accelerations, how much, and what is the relations between these mass of mass of the earth or distance between that types of the earth and gravitation constant. Then today's lectures we are started discussions of the first important concept, that is the satellite. In the basic known of the satellites, whenever we listen these types of the words, we know about the NASA, ISRO's, or the space science, that types of. But the basic definitions or basic meaning of the satellites is the every object which are revolving around the Earth or which are revolving around the planets. It means the moon is revolving around the Earth. This is the natural satellites of the Earth. Moon is the natural satellites of the Earth. Whenever we are doing certain project or the types of the scientists we are doing certain project or space science, they are be launched certain satellites. The mainly two types of the satellites, and the man-made satellites or launching satellites is known as the artificial satellites. The basically two types of the satellites. First is natural satellites and artificial satellites. First one is a natural satellites. natural satellites. The example will be the moon is the natural satellites of the earth. The moon is the natural satellites of the earth. The examples will be moon. And artificial satellite, there are man-made satellites. These artificial satellites is again classified in the two different types of the satellite. One is the geostationary satellites, another one is the polar satellites. These satellites is classified on the basic of the motions, orbits, and the motions of that particular satellites. Orbits and the motions of the particular satellites. The first artificial satellites will be geostationary satellites. Geostationary satellite. This is also called a geosynchronous satellite. Geostationary or geosynchronous satellites. In the 10th books, there will be the GSLV. Geostationary launched vehicles. Geostationary launched vehicles. These are rockets is known as geostationary launched vehicles. These geostationary satellites is one of the types of satellites such as they looking like a. This is the basic diagram about the satellites. The both are symmetric. Both planets or sorry, both plates are symmetric, and this is the certain orbitals or anything. And these satellites how to be launched. These satellites is a compact one of the object or one of the machines. These satellites is makes compactness and held by the machines, and these machines is a launched vehicle. These vehicles is launched. This vehicles is known as rockets. Rockets will be launched, and after this they will be emits this type of the satellites. Geostationary satellites. It is the satellites which are moving as like the motions of the earth. It means this is the orbital satellites. This the orbits of the satellites is all about the orbits will be 38 thousand kilometer to the 35,000 kilometer. The orbits will be 35 to 38,000 or 38,000 to 35. This is the range of between the 3,000. 35 to 38,000 is the range of the orbits. This is the distance from the Earth surface to that particular orbits. Consider this is our Earth, and we are launching these particular satellites at that place, and this will be moving like this. And the motion is similar. Motion is similar to the Earth. What about this meaning of the sentence? The motions of the earth will be like this. The motion is moving in that arrow's direction. It means the satellites is also moving in that directions. The satellites is a study. This satellites is study. Geostationary satellite is study about the planetary motions or the certain objects around the or in the space. Then this is the moving. But whenever we this satellite is watching that place or particular places on that particular Earth surface, that continuously watching or under the surveillance is the same area. म्हणजे काय करत असतो इथून हा जर सॅटेलाइट्स इथं एखाद्या पर्टिक्युलर इंडिया जर वॉच करत असेल, दे आर कंटिन्युअसली वॉचिंग ऑन द इंडिया. It means the time period of the satellites is similar to the time period of the Earth. Time period is also similar. Time period is similar to Earth. Earth is taken to complete the one revolutions or one rotation itself is taken 24 hours. Then this stationary or geostationary satellites is also taken the 24 hours to complete the one rotations. The motion is similar to the Earth. Then the motions or the speed of the satellites is more than the speed of the Earth surface because the radial will be more. If the radius is more, the path will be calculated by 2 pi r. the radius, and the 2 pi r is the path, total path covered by the particular satellite, divided by t. T is the time period. Then distance upon time equal to speed. T is the 24 hours. R we know that this is the R, and the and again we add certain radius, the radius of the earth, 64 or something, 64,000 kilometer or something. This will be radius of the earth plus this radius added, and calculated the path of geostationary satellites divided by 24 hours. Then we get the speed of that particular satellites. These satellites is known as geostationary satellites. The second type of the satellites is polar satellites. This is the polar satellites. And again, this satellite is known as PSLV, Polar Satellites Launched Vehicles. This satellite is known as PSLV, Polar Satellites Launched Vehicles. Then the orbital range is as in between the 100 kilometer to the 500 kilometer. Orbital range is 100 kilometer to the 500 kilometer. This is parallel to that particular Earth. Then the orbital range is less, much more less as compared to the geostationary satellite. Orbits or the radius of the particular polar satellites is much more less than as compared to the geostationary satellites. The motions is against opposite. This is the another type of the motions or as similar to the earth, and this motions is the south north motions. South north motion, this is the equatorial motions, and this is the south north motions. Basic difference between the GSLV and PSLV. GSLV is the equator motions. Earth is always follow the equator motions, but this is the another. If this is our earth, or this is our earth, and earth will be, this is the axis of rotations of the earth, and earth is motions like this. Earth is motions like this. It means the geostationary satellites is also movement like this. But the polar satellites, if the earth is motions like this, then polar satellites is motions like this. Another motion, it means the axis of rotations of the particular satellites is like this, and this will be movement. This is the difference, basic difference between the motions of GSLV and PSLV. Then the time period is much more less, and the time period of the particular polar satellites is much more less. Then the polar satellites is used for the weather forecasting, mapping of the particular area. This is used for weather forecasting. Weather forecasting and maps or mapping of the area of that earth. This is all about the basic information of the satellites. Satellites, it is the object which can be revolve around the earth or revolving around the planets. This is called as satellites, and we are discussed the two different types of the artificial satellite, that is geostationary satellites and the polar satellites. Geostationary satellites and polar satellites will be revolving in the different types of the path or perpendicular path of the each other. If they are revolving like this, they will be also opposite or perpendicular to each other. Then the orbits of the GSLV or geostationary satellites is all about the 35,000 kilometer to the 38,000 kilometer from the surface of the earth. But the orbits of the polar satellites from the earth surface is 100 kilometer to the, this is not a meter, this will be kilometer, 500 kilometer from the earth surface. If there are 500, we can easily touch whenever we going to terrace top the building. Then south, this is the south and north motions. This is the opposite motions of the earth. Or perpendicular motions of the earth which make the 90 degrees of that motions, south and north motions of the polar satellites. But the geostationary satellites is also equatorial motions, or this is the motions as similar to earth. The time period of the geostationary satellites is similar to the time period of the earth. When the earth will be covered one one rotation itself in a 24 hours, then the geostationary satellite is also taken the 24 hours to complete its one rotations. Then the polar, this is used for the certain changes, and they are also focusing on that particular points. And these polar satellites is used for the mapping and weather forecasting weathers. Then how can we changes the wind forces, pressures of the winds, or certain changes in the seas will be studied from the polar satellites. Then now there are most important concept which is start to discussions here. This is the projection of satellites or the motions of the satellite. How can the satellites is launched? The satellites will be launched with the help of the vehicles. These vehicles is known as the rockets. But the motions, how they will be reaches or how they will be escape from the earth gravitational influence. Earth gravitational influence it is the field, and gravitational influence it is gravitational influence means the range of gravitational field or area of the gravitational field. Before the discussions, we are just studying what are the types of velocities to give the particular satellites. Whenever we launching the vehicles, or whenever we launching the vehicles or the rocket, this is the our earth. Consider this is our earth, and we are launching vertically launching their particular satellites. This is the point P. Then we are give certain velocity or certain force to the motions of that rockets in vertical directions. At that place there are much less of the gravitational force. At that time we are making such a movement or changes the directions of the rockets, and this is the horizontal directions or tangential directions. Whenever we make the tangential, this is the vertical directions. This direction is the vertical direction. This is the horizontal or known as the tangential directions, and it make the such a path which are revolving around the earth surface. But these velocity which is make the horizontal path, this velocity known as vh, that is the horizontal velocity. Vh, firstly please take the heading, that is the projection of satellite. Projection of satellite. Before the discuss the projection of satellites, we need to discussions about these certain velocities or certain basic concept about this. When we are trying to move this particular object or this particular vehicles from the earth gravitational influence, for the movement or for the motions, for the escaping that particular object, we need certain force to apply on that particular vehicles. We need certain velocities of that object. Then this velocity will be calculated in the different things. The first is a vh, horizontal velocity. This horizontal velocity is also known as tangential velocity. The velocity which is applied at the point of projections, or the velocity which is opposite or 90-degree directions of that particular vertical direction. This is the horizontal velocity which tries to revolving around the earth. The velocity applied or horizontal velocity applied at the point of projection, at the point of projection. P point is known as the point of projections of the satellite for their horizontal motion. For their horizontal motion, the horizontal velocity vh is applied, certain velocity is applied at the point P. This point P is known as the point of projections, which makes certain velocity for the horizontal motions of that particular vehicles or particular rockets. Then this is the horizontal velocity VH. We are denoted VH. Another one types is, that is VC. This is also known as circular velocity or critical velocity. Critical velocity. The applied horizontal velocity, the applied horizontal velocity is makes the path of that projection is circular, or the circular path velocity is also known as the critical velocity. The velocity which is required to revolve the particular satellites around the circular orbits of the earth, along the circular orbits of the earth. The velocity which is required to that satellites, to motions of the satellites along the circular orbits around the earth, this is called as critical velocity. Velocity required for circular orbit, for circular orbit, this is known as the critical velocities. The velocity of the satellites which is required to motion or to revolving around the earth's surface in the circular orbits, this is called as the critical velocities. Now last one is escape velocity, VE, that is the escape velocity. The velocity need of that orbits, the velocity is need of that object which are moves from the earth gravitational influence, which are escape from the earth gravitational influence. This is called as the escape velocities. These three velocities are required. These are basic informations about the three velocities required to study the projection of satellites. Then first things, we are applying certain force on the rockets at the reach the point of projections. At the point of projections, we change the directions of that rockets using the remote control, and these make horizontal directions. At the time, we can apply certain force or thrust on that object or rockets to change their velocities, and this velocity is known as the horizontal velocity. If we does not apply certain velocity after to making the directions horizontally, then at that times the earth is applied certain force, certain attractive force. This force is known as gravitations. They pull this object towards to earth, again they comes to the surface of the earth. Now, let's start to discuss the actual concept, that is the velocity. Then, case 1. When the horizontal velocity Vh is less than critical velocity. Firstly, let's study what is the horizontal velocity. The velocity required that object or the velocity applied of the rockets after to changing the directions or make the horizontal directions, the horizontal velocity of that object. Vh is less than Vc, then the object path will be, path of that rocket is elliptical path. Is the elliptical path. Elliptical. Then as this is the elliptical path. This is like this. Elliptical path. Whenever this condition is a case for case 1, and Vh, the horizontal velocity is less than critical velocity. When the horizontal velocity is less than critical velocity, then the object or the rockets is revolving in the elliptical orbits. Then sun is or the earth is situated one of the focus, and this is the opposing. opposite. It means the distance, the elliptical distance from the Earth surface is less. This is the less distance. This is the apogee. And this is the elliptical orbit. Then case 2. Second case. What happened in the second case? This is the all about basic information. If you want to detail information, let's see in the my first or 11th standard physics. Then at that time we are totally studied in detail about the projections of satellites. Then the case 2, the horizontal velocity Vh is equal to the critical velocity. What about the critical velocity? The velocity which is required of that particular object which revolving around the Earth surface along the circular orbits. It means the orbits will be the object or the rockets or satellites follows circular orbit. What is the, how can be drawn the circular orbit? And sun is the center. This is roughest diagram. This is must be circular, and this is the second condition. At that time Vh is equal to Vc. Vc is the critical velocity which makes the circular orbits along the Earth. Then the satellites which are follows the circular orbits, when the horizontal velocity applied as equal to the critical velocity. Then third one types, that is the case 3. Case 3. About the case 3, when the horizontal velocity is the right like this. Horizontal velocity is greater than critical velocity. Horizontal velocity is greater than critical velocity, and also which is less than the horizontal velocity is greater than critical velocity and less than escape velocity. What is the escape velocity? Escape velocity, it is the velocity which is required that or object which escape from the Earth gravitational influence. Then this escape velocity is called this velocity is known as escape velocities. Then at that time, which is again follow the elliptical orbit. And at that time the distance from the orbit, distance from that particular orbit from the sun is much more larger. This is the another types. This is the third conditions. Vh is greater than Vc and less than V. At that time, this is the apogee, and the Earth will be much less. Difference between the another point from the Earth is much more greater as compared to the first case. पहिल्या केस मध्ये काय झालं होतं, जेव्हा हा इलेक्ट्रिकल ऑर्बिट फॉलो करत होता, ॲट दॅट टाइम द पॉइंट ऑफ प्रोजेक्शन आणि हा जो अर्थ पासून जो काही ऑर्बिट आहे तो जवळ राहत होता. बट या टाइमाला काय झालेला आहे, तो पेरिपोजी झालेला आहे. अपोज द डिस्टन्स फ्रॉम द अनदर पॉइंट ऑफ द अर्थ इज मच मोर ग्रेटर दॅन. कंडिशन्स काय होत आहे की जो काही अर्थ पासून आपला जो काही व्हेइकल्स आहे तो एस्केप होण्याचा ट्राय करतो. फर्स्टली काय झाला, या डिफरन्स कमी होता. सेकंडली हा डिफरन्स काय झाला, वाढलेला आहे. ॲट द टाइम थर्ड विल बी मच मोर ग्रेटर डिफरन्स. देन ॲट द टाइम इज पेरिपोजी. अपोजी अँड पेरिपोजी म्हणजे काय असणार आहे, आता हा काय झाला, पॉइंट ऑफ प्रोजेक्शनच्या डायरेक्शननी काय झालेला आहे, अनदर सेंटरकडे जायचा प्रयत्न करतो, किंवा अर्थ इज मुव्हिंग अनदर फोकस. जो डिस्टन्स या दोघांचा होता तो आता कमी होणार आहे, बिकॉज if we increase the velocities. Again we are saying the case 1, the horizontal velocity of the vehicles or rockets is less than critical velocity. Then these orbits will or this object is follow the elliptical orbit from the Earth surface, and Earth is the situated opposite or the near to the orbits. Then to increase the velocity at that time, the horizontal velocity is equal to the critical velocity. Then at the time the satellites is follow the circular orbits. The orbit of satellites is circular. This is the circular orbits. Then third part, case 3, at the time the critical velocity, the horizontal velocity is greater than critical velocity and less than escape velocity, just less than escape velocity. At the time it make again elliptical orbit, but the tip of the orbits or tip of the elliptical orbits is much more farther than the Earth. This is the periposition. Then again two conditions discuss and stop here. The horizontal velocity, the velocity required, or the horizontal velocity which is required to motions of that particular object after the changes of the directions. Then what is the escape velocity? The velocity which is required to escape the object, escape the satellites from the Earth gravitational influence. Then last, critical velocity, the velocity required of the object which are moving around the Earth along the circular orbits. Then case number 4. Case number 4. At the time, the horizontal velocity Vh is equal to the escape velocity. We are trying to increasing the velocities. We are increasing the velocity because we are escape these particular orbits from these particular satellites from the Earth gravitational influence, because we are launching. This is the place the moon will be lies, and we are trying to escape or we are trying to landing these satellites on that particular moon or particular any another uh, planets. Then V as the horizontal velocity is greater than the equal to the escape velocity. At the time, the path will be path of satellites. The path of satellites is a parabola. Path of satellites is parabola. This is the parabolic path. We use the different color. This is the parabolic path, and the fourth condition, that is Vh is equal to Ve. Ve is the escape velocity, the velocity needs or required to the satellites which are escaped from the Earth gravitational influence. Then another one, there is last case, case 5th. This is the last case when the horizontal velocity is greater than the escape velocity. If we apply the velocity is much more greater or slightly greater than the horizontal velocity, escape velocity, then that time this will be escape from the Earth gravitational influence. The Earth gravitational influence. And the path will be the hyperbolic path. This is the case 4. Vh is greater than Ve. This is the path number 5th. This is the hyperbolic path. Hyperbolic path. What we are studying in this lecture? Firstly, what is the satellites and how they can be worked, and what is their main purpose to create the artificial satellites. Artificial satellites must be created to watching the planets or watching our particular areas, any countries, and again to gives the whole informations about the weather forecasting, again communications, This is the geostationary satellite. Is a communication satellite. We can easily watch the movies. We can easily watch the live matches, live sports matches with the help of the satellites. We can be called to every person, or we can be talk every person from the larger or farther distance, or which is any point on the earth, because this is due to satellites or geostationary satellites, communications, and any another purpose we are used. Then the satellites, how can we work or how can we escape from the earth gravitation? They are how can be launched? Whenever they are apply certain velocity or certain force, they are moving at the point or at particular or from the certain distance from the earth, or this is the vertical distance, and at that distance we are trying changes the directions of the vehicles which are tries to taken certain satellites, or some satellites they may be polar satellites or geostationary satellites, and at that time we change the directions. After that changing the directions, we are applying certain velocity for their motions. When we don't apply that velocity, these satellites is again comes towards to the earth, and again on the strikes on the earth surface, because the earth gravitational pull. Then we applying certain velocity. There are horizontal velocities much less than critical velocity. This is the case one. The path will be followed. This is the first white color path of that particular. Whenever we applying the horizontal velocity is less than critical velocity. What is the critical velocity? It is the velocity which is required to motions of that orbit around the of that vehicles of that satellites around the earth surface in the circular orbits. Then the path is elliptical path. At the elliptical path, the tip of the particular planets or tip of the particular orbits is much more or less. The distance between tip and earth is less as compared to this point of projections. Then again try to increase the velocity, horizontal velocity of the satellites. Second is critical velocity. The horizontal velocity is equal to the critical velocity. At that time the satellites is under the motions of circular orbits, because the critical velocity is velocity required to follow the circular orbits. And third, the case 3, the velocity or applied velocity, tangential velocity or horizontal velocity is greater than the critical velocity and less than the escape velocity. Escape velocity, the velocity required to that particular object or particular satellites to escape from the earth gravitational influence. They are again elliptical orbits, but the point of projections and earth distance is less than the another tip of the ellipticals. This is the peripogee. Then the condition 4, the horizontal velocity is equal to the escape velocity. The horizontal velocity is equal to the escape velocity. At that time, they will be follow the blue path. This is the parabolic path. The satellites will follow the parabolic path when we applying the horizontal velocity as equal to the escape velocities. Then the case 5, the last case, what happened when we apply the horizontal velocity is greater than the escape velocity? They follow the hyperbolic path. It may be escape from the earth gravitational influence. Then what happens? We are want to launch these vehicles on the moon surface. The process will be same reverse process. At the time we are trying to throw or the escape this particular orbit, these object or these rockets from the earth surface, and on the moon. On the other case, we want to landing that process. The case will be reversed from fifth case to the first case. At that time we are reduce their velocity, horizontal velocity first greater than the escape velocity, then we are trying to equal the escape velocity of the moon. Then after that times we again moving with the third case. Third case is the critical, it is greater than critical velocity, and again the path is reducing, and at that time the last path will be like this. And At that time, whenever again less the velocity, this try to landing on the surface of the moon. This is the different or opposite cases. Maybe in the next lectures we are just study about the next concept on the gravitations, or maybe in the next chapters the mechanical properties of the fluid, or mechanical property of the object, or mechanical property of the solids, liquid, gases, anything mechanical property of the matter. And one day we are discuss the Chandrayaan 3 motions of the Chandrayaan 3, how can we land and how can we project from the earth surface, will be discussed in the one special lecture about the motions of the Chandrayaan 3 or mission Chandrayaan 3. And in the next lectures we are discuss the mechanical property of the matter. Okay, thank you.